Okay, so let's start from where we left off. So as I said, that subqueries can be part of a field list, though that's not the best example I've given, but they can be part of the field list. And you also, if nothing is asked, you can make your own educated guess as to which join or subquery will be better. But if specifically asked, and I will be asking it so that you know, in the assignments also and in the exam also, I will be specifically asking you to answer using a join or using a query or whatever, right? So you have to know everything kind of. Again, keep in mind in the exam you will be allowed to use any class examples that we do, definitely, and your assignment also. I'm not sure if your marked assignment will be back by that time. Since you're on Thursday, maybe it will be, but I'll give you the solution for sure, so that you have the solutions with you. So once everything comes to me, I can put a solution on Blackboard. Okay, let's look at this one. It says list everyone who lives in the same zip code. The zip is coming from your contacts file for your information, as the person with the highest current salary. So we know from where the highest current salary will come. Definitely it will come from the job current table. And then all we have to do is we have to look for all people who are living in the same zip as this person's zip. So we need to get the current salary of the person, then we need to get the zip of the person, and then we want to get all those persons who live in the same zip. So again, if you kind of think of it, you can do it either way you like. For me, subquery is just easier to do, so we'll do it using subquery, and then we can look at joins, right? And again, I am emphasizing, it's just whenever there is something which says I need a value, it says, oh, if you need a value, then we need to have a subquery for sure. Though it can be a combination, you can combine a join and a subquery, that can be done, and that you can make it efficient, or you can put it in a variable, but still you will need it somewhere. Okay, so let's get the person with the highest salary first. Just because I know it, I'll kind of put it. So let's select. It's just more work here. I mean, we've kind of done the similar things. Okay, so let's select the highest the zip of the person who has the highest salary. Okay, so the zip is coming from the my contacts table, right? I mean, it's an educated guess because information about contacts is in the my own contacts table. So the zip is coming from the my contacts table. Thank you. Okay. Okay, so this person, the zip from the table contacts is that zip where this person has the highest salary, right? The person with the high. Oh, now if there are two persons, so that is a set. It could be a set, right? In our case, it could be a set because we have two persons. And anyway, we don't even have to peek into the data. We have to just think, can more than one person have this highest salary? Yes, they can. So this is a set then. It is a list. Let's not call it a set. It's a list. Sets don't have duplicate elements. And you know what? No, we can do a distinct in here because people may be coming from different areas. Oops. Okay, so it is a list. Okay, so let's try. So select the zip from table contacts where the salary of this person, right? Where the salary of this person, no, wait. Oh, no. Where the contact ID of this person, there is more to do. Okay, let's see. I want to find out the zip of those persons. Okay, so let's do one at a time. Okay, so let's select the highest maximum salary from the job current, one job at a time. Guys, soft please, right? That's the maximum salary from the job current, table job current. So, okay, so now we want to find out this person's zip. Okay, so we need to find out this person's contact ID. Select the contact ID of this person, which could be a set from the table current, job current. where his salary is equal to this salary, right? Okay, so we are getting the contact ID of this person or persons whose salary is equal to this salary. Okay, so let's go one at a time. So that's one done. That's the second done. Okay, so there we are. So now we have this person's contact ID. And now we need list everyone who lives in. So list everyone means something like a name or whatever, right? So let's just say name. How else will we list everyone? So I mean, if nothing is mentioned, you could do a star. Nothing stops you from doing a star if nothing is mentioned. If it says list everyone, then no fields are mentioned. Okay, from what table are we interested? On this table. Now, where is this table? Where the contact ID of this person in. Remember, because we are getting a set. Let's see if it is making sense. No. It's only those persons where, oops. Okay, so the zip is, there's more to this. We have to find the maximum salary getting the contact ID now getting his zip. Uh-oh, okay. Label my contacts. We have to get his zip first, right? Now what? Get the zips where this contact ID is in this table. Okay, so we need more brackets. Okay, so let's see. So get the maximum salary, get the contact ID of this person or persons whose salary is equal to the maximum salary, then get the zips from the table where that contact ID is in this table. Oh, you know what? Yeah, looks like it should work. Where now we do select from table contacts where zip in this table. Okay, now look for your, that's one, that's two for this table. That's the third one for this, that's the fourth one for this, and that's the fifth one for this. Is it making sense? Zip of all information about those people who live in the same zip as the person with the highest current salary. Okay, so that's the highest, that's the current salary, highest current salary, right? Now we need to find out all those persons. I mean, what is common? I will have to find out all those persons who have this maximum salary. Once we have that, we want to find out the zips of these persons. And then we want to find out all other persons who live in the same zip. Is my thinking. Is my thinking. If we need less number of brackets, please remove any brackets you don't need. So we need this. Oh, don't you think this bracket is extra? Because this already has a bracket, right? Then this bracket seems to be extra too. Yep, there it is. So no extra brackets required. So basically each select in its own bracket is what we need. So there are 3 selects, so we need 3 brackets. So who had the maximum salary? There were 2 persons with the maximum salary, that 1200. We'll have to look at those zips and anybody else who lives in that zip. Oh, okay. So it's a little bit of work, but let's see. Let's see if the answers are correct. So the maximum salary was 1200 and 1200. So we had 2. So book show 6 and 8. Not 6 and 8. 5 and 8. 5 and 8. 5 and 8. So let's go to 5 and 8. So 5 and 8. 1, 2, 3, 4, 5. Let's go it from here. 1, 2, 3, 4, 5. 55, 467. Just so that we know. That's the zip of the person with the maximum salary. and 5, 6, 7, 8, 7, 7, 5, 6, 7. Okay, so those are the zips of the two persons with the highest salary. Anybody else that matches it? We definitely have this guy here, 2. Then we have, no, this one, there's another one, 7, 8 or whatever, 7. 2 that are matching 5, 5, 4, 6, 7. There's nobody matching 7, 7, 5, 6, 7. Right? Okay, let's try. So 1, 2, 3, 4, 4. Okay, let's try. Yep, 4 of them, right? And notice we can kind of look at this one. So these were 3, these were the other 2 who were matching. I think Renee was number 5 and Angelina was number whatever, right? So these are the 2. So the answer is correct. Because the 2 salaries, the 2 zips that we wanted to match were these. There was no matching for this, but there were two persons who were matching this, which was record number 2 and record number 7. So record number 2, record number 7, 5 and 8 is what we need, right? So if you kind of look at it, Kenton Leo is record number 2. Then 1, 2, 3, 4, 5. Hamilton Jamie is 5, which is the person who has the salary. Then Renee is matching it. And then the last person was Angelina, right? So the answer is correct. So again, to me, and I'm not saying it could be the best way. Of course, you could do it using joins if you like. But for me, whenever I have to say, oh, I need the maximum salary, I do need a subquery somewhere. For the last part, I definitely need a subquery. The other you could maybe join. So if you kind of look at it, what are we doing? We have a table my contacts and we have a table job current. We could maybe join the 2 tables. All we have to do is the salaries should also match and the zip should also match. So give it a try if you want, right? Give it a try with joins. You definitely need a subquery. So if you don't need a subquery, you will have to put it in a variable and you can use that in the variable. So if you say, oh, I don't want to do it, I only want to do it joins, we'll take this value and put it in a variable. Once we have it in a variable, then we can use it in a query, right? And I think we can do it because what's matching is table my contacts and table job current. You have to match those 2 tables and their zips should be same. It can be done. It's not as if it can be done. It's just more I think way of looking at it. To me, this just seemed the easiest, not the easiest. I mean, in a sense, if you kind of say easiest, I said, okay, select the maximum, then the contact IDs of those people, then their zips, and then the zips of the other people. This is how I thought it out. Again, there is no restriction. I'm sure we can do it using join by putting the value of max salary in a variable and using it. So give it a try yourself, and if not, then let me know. I can try it. I didn't try it, right? Excuse me. What I want to bring your attention now to is also, after I write the outer join anyway, for this correlated query. That's kind of a little more complicated than any queries you've done, but you have to do that anyway. Name and email of all contacts who currently do not have a job. So remember, do not have a job. Whenever there is a do not, you can kind of think of where it is coming. So we had a job current, we have a job desired, and we have a job listings. So do not have a job means they are in my contacts, but they are not in job current. These are people who don't have a job. Okay, so now which table should be the main one? If I can go from here to here, they're all there. Okay, so I'll have to go from my contacts to the other table and look for people who do not have a corresponding record. That's what we do. Okay, let's try it. Okay. So whenever, the one thing where it will always work is the do not. Do not will always work with an outer join, right? You can always do it. But now you have to be careful. Which table do I join with? Which other table? Okay, so let's do name and email. Again, I don't know what, like if it says name and email, you could concatenate it. You could just put it first name, last name, comma, and the email. Right, so these are coming from which table? From the table my contacts. I can definitely do an inner join also. I can say the name and email of all those persons who currently do not have a job, do an inner join, and the condition is What is the condition? Do not have a job. Oh, there will always be a partner. Oops, no, no. It will have to be done doing an outer join. Okay, so let's see. Left outer join. Right? And do a left outer join with what is the other table? TBL job current. Okay. So you've combined two tables. You've combined the table contacts with the table job current. Which records do you have to pick up? Only those people who do not have a job. Do not have a job means you couldn't find a partner. Couldn't find a partner means that the second field is null in the other one. Okay, so complete that. Do your condition first. You can do using. Can we do using? Yes. Okay, so using on contact ID. And now the where condition. So the second, what can we pick up from the second? We can pick up the contact ID. We'll just have to kind of qualify it, right? It's contact ID. Couldn't find a partner. Is there, couldn't find a partner. So the do not usually works with outer joins. Inner joins no, because inner joins won't work because you're trying to say it doesn't match, then the first one doesn't match will match with all of them. No, no, inner join won't work in this one. Right? So the outer join is saying pick up a record from my contacts, find a partner in job current, and if you can't find a partner, that's the person who doesn't have a job. So here it is important that I pick up the record from contacts and look in the other table. I can make it opposite. Because I want to look for people who do not have a job. So everybody is in the my contacts. So who doesn't have a job if they are not in the job current? Can go the other way. Can go from the smaller to the bigger table. So that's your outer join. So people do not have a job. The student and the unemployed, 7 and 10, right? I think 7 and 10 were the two people who didn't have a job. How do I remember? Because those are grayed out here. I commented them. I said people like to put them. There they are, 7 and 10. Right? 7 and 10 are people who don't have a job. I don't know who these guys are, but 7 and 10 is what they are. So 1, 2, 3, 4, 5, 6, 7. No. 1, 2, 3, 4, 5, 6. Renee doesn't have a job? How is that possible? Renee has been coming in all the tables, right? Am I looking at the wrong table? 7 doesn't have a job and 10 doesn't have it. This is job current, right? Yeah. Who is 7? Am I counting going wrong? Did I remove a record? No, I don't think so. Okay, so 1, 2, 3, 4, 5, 6, and oh, this is Renee Crow. But that Renee is coming in many other records, but we were trying to find out with her salary or something, wasn't it? That's what 7, 8, 9, and 10. These guys don't have a job. Or maybe she was coming in people looking for a job with computer programmer. It was coming somewhere for sure. Okay, so let's execute the query. Query completed. And there it is, Renee and John. Right? So yeah, we've seen Renee before, but maybe when we were looking for who is looking for a computer programmer job, because we've seen her before, right? So definitely in computer, and who are ready to take a salary of less than 95K. There is where the record was coming up. Can happen, like you can be wrong. So there, that's what it is, right? So we've done it one way. Let's look at the other way since I've mentioned them. It says do a subquery. What do you think we'll do with this subquery? Basically find out all contact IDs who have a job and then pick up people whose contact ID is not in that table, right? So let's try it again. So pick up the first name and the last name from my table contacts. Okay. And this person should not be in where the contact ID of this person. So pick up only those, pick up only those people whose contact ID is not in the other set, right? What is the other set? The other set is basically select the contact IDs from top current. Perfect. So sometimes it seems that they're easier, subqueries are easier, but as I said, they are less efficient than joins. I don't know why, but if I mean, a subquery says take something from a table and use it. So maybe it involves more It's just a table, but that's what it says. Maybe I have to read a little more. Maybe in some cases it is, but they say subqueries are just more complicated in the sense they are less efficient, not complicated, less efficient. When you look at them, sometimes it seems more that's much easier. But anyway, that's what it says. So select people who have a job, right? And then select all those people who do not have a job by saying the contact ID is not in this. You should have the same answer again. First name, last name, and there it is, right? So the query completed, yes. Right? And now the third way, which you haven't seen before, but let me show you. These are called correlated queries for a reason. Why they're called correlated queries is because you're trying to pick up a field that is not from the current table, but it is coming from another table, which is in a subquery. Let me write it for you, and then I'll explain it. So it uses the verb exists and not exists. And it's not very straightforward and logical way that you read it and you will get it. It's just how you have to look at it. What do they mean? So let me write it for you, and then we'll do it. Okay, so we'll do the same selections. Right, we'll do the same selections. I need the first name, the last name, and email from this. And again, I haven't done it. I should, but anyway. Okay, so this is how you write it. You say where there does not exist. So kind of bear with me for a minute. Let me write the syntax first. I'll just give it a okay. So now we want to say find out all those records. Okay. And as I said, it's not always very easy to read or understand. Select all the records from job current, and I'll tell you why it is called correlated. Where the MC, I mean, I could have written the whole thing. I've been saying I'll write it and then I don't use it. Contact ID. Okay, so select all those records where the contact ID is same. Again, just so that, okay. The names are also not case sensitive. I just write them in caps so that they're easy to because it's an abbreviation also. Okay, now let's see. Give me a minute. I think I'm right. Yeah, okay. Let's see. Now look at it. Please pay attention. It's not necessarily the only way, because we've seen two other ways. We've already seen how you can do it using a join, and we've already seen how you've done it using a subquery. This is also an example of a subquery, except it's called a correlated query. And look, why is it called correlated? It's called correlated because the inner subquery, the inner, not the outer, the inner subquery is using the outer table. So the outer table is MC. Why did I use my contacts in the outer one? Because I have to pick up fields from that table. And what you are saying, so there is a where not exists and there is where exists. So you're basically saying this. Think from this point of view. You're saying select all the records from the job current table such that the contact ID of this job current is available in the contact ID. So what do you have? All people who have a job. All people who have a job. All the records who have a job. You have a table. You have all the records who have a job. And then you go to the contact side. You pick up a record from there and you say, does it exist in there? Does it exist in there? So if it does not exist, these are the people who do not have a job. So as I said, not the most straightforward one, but this is called a correlated query just because in the inner subquery, you're using a field from the outer table. And I just gave them names because I've been saying I will give them, but I don't do it. Right? So you could still just qualify them by table my contacts and table job current JC. So kind of think of it this way. It first finds out at line number 328, it selects all the records from the current table such that the contact ID of that record is equal to the contact ID in the MC table. So now what do you have? All those people where there is a match, right? Where there is a match. And then you are saying now find all those people who do not exist in this set. I personally don't like it a lot just because it's more complicated and not as straightforward, but it does exist, and the verbs that you use are not exist and exists. That's what you use. And it's called a correlated query and you've never seen it before. You haven't done it. Anything that's in the inner table has to be used in the inner. Anything you're using in the outer, because they're two different queries, right? Two different subqueries. They don't talk to each other. But in this case, you're talking to each other. You're basically saying that the contact ID of this MC should be equal to the contact ID of the JC. So you're doing something. So that something is where you say, call it a correlated subquery. So you should be aware of these verbs. Necessarily may not that it will have a solution everywhere, and maybe you won't even choose it because it's not so straightforward. To me, this is more straightforward, where I say your contact ID is not in that table, or maybe this one is more straightforward, right? But this is not straightforward, but it does exist, and the verbs are exist and not exist. So whenever I get a chance, I'm not sure, maybe if I've done it in 7 says find all those job titles. I think I can show you in this one, the exists. All those job titles that are desired and are in. Whenever there is an are in, it will be an exist. And wherever there is not in, there will be a not exist, right? So let's try to do 7 now. There was a 7B also, is there? Oh, more than one jobs, which is kind of okay. Okay, so all job titles that are desired, means job desired and are in job listings. So this is, let's do it with the join. So these are, find all those job titles, just the title. Okay, so select. I'm not sure, will we need to? We'll definitely need to. Okay, so job titles that are desired. I'll just call it JB now, right? Job JD, job desired. Can't do much about it. I don't think I can debug it. Oh, well, did we run it before that? I think we did, right? Oh, not the last one. Oops, can't do much about it. Oh, haven't lost anything. There. Okay, so job titles, so job desired. Just going JD, okay? Title from there. That are desired and are in job listings. Can we do an outer join? This is just saying match something from here and go here. Yep, so let's just do an inner join. And we can do a natural join here, right? Because we can do a using here, whatever makes sense to you. Okay, so from what tables? From the TBL job desired, and I've called it JD, right? And what is the other table? The table listings. So this, if you've seen a table before and you kind of get used to it, writing queries on it, then it's kind of easier to do it in an exam, right? Because you've seen the table before. And that's what I'm kind of thinking in the assignment and my exam. Okay, so we need the title from these two tables. And again, you know what? We can even do the easiest would be to do even a natural join. Like nothing stops you. I mean, you can write it many ways you like. Get used to everything. So I'm basically saying I need you to pick up those job titles that are here also and in the other one, and basically just doing a natural join. People who desire, I may have to use distinct, right? Because there were two people who wanted computer programmer jobs, which is okay. Like it's not wrong, but if you look at something, then again, so you can use a comma, you can use inner join and write it whatever way you want. I just went with this one. So let's try that. So there were 3, 2 with computer programmer and 1 baker, remember? So 1 baker and 2 computer programmers. Now, if it is not a requirement, then we can always say distinct in front of it. It's just saying what jobs titles are desired and are in the job listings. So just go distinct. There. I'm not peeking in the table. I just saw the result and I said, I don't want to see computer program. If that's the aim. Now it's in 70, if you notice, I said the count is greater than 2, more than 2 people desire. So then it's okay. Like if you need to, maybe sometimes just people want to see it whatever they are. So you can leave it. It's not necessary. If I say show me unique, then definitely I need distinct, right? Okay, the second one is saying it is a subquery. So the subquery basically says we will have to select. Okay, so let's do the same title. I'm not sure if we will require distinct. In a minute, we'll know. So we want to select all those titles from here where this title is in. Right? This title is in which table? Select title from job listings. I think we'll require a distinct again. We can try both ways. So this one is simply saying that find out what jobs are available in the job listings table. What jobs are available in the table, and then pick up only those jobs from job desired where the title is in here. So again, you didn't have to do this at all because you're in one table. You know what I mean? Like if there is no problem, then you don't have to. So you're basically saying title from this table, where this title is the title from the other table. So there is no ambiguity at all. Some people prefer to always give their tables that they're joining or in a subquery alias names and then qualify every field, which is not a bad idea at all. Like it's not a bad idea. But you have to understand that where is it required or where is it not. So I think, do we need distinct? This will give, yeah, this will give programmer and baker and whatever, and then yeah, it will require distinct, right? Let's try. And again, keep in mind, in the job listings, I only have one kind of a job. But it may happen that the computer programmer is listing two jobs with computer programmer because maybe they're available in Toronto and Barrie. So you will have to use a distinct there also. If, you know what I mean? Like again, so we don't know. So to be on the safe side, we can do a distinct here also. It's not safe, it's just saying, what are the jobs that are available? That's all it is saying. So it could happen that in the job listings, you have two computer programming jobs. It's a logical assumption. There's nothing wrong in it. So I just want a list of listings and then I want a list of titles. Okay, so let's try that. So this listings has been put by me just in case there are more than one job listing, which is, it's a valid assumption. And there's nothing wrong in seeing duplicates. I mean, there is nothing wrong in seeing duplicates at all. So there it is. So the last two results, notice they're just in a different order. One is computer programmer and baker, and one is baker. So again, how the engine is working and how is it doing the query, we have no idea. Therefore, we say the rows and the columns don't have a significance in terms of their positions, right? So I'd put a distinct here, thinking that what if there is more than one job of the same nature? Now let's look at this correlated query. So the correlated query simply, again, we will still be selecting titles from this table. Okay, so for a minute, let me think. So this won't matter. Right, this won't matter. And again, here, just because it's a correlated query, I know I'll need it in the inner table. So see what it is saying. It's saying where this record exists in this record. And I just use a select star here because it doesn't matter, right? For me, I'm not interested in this field. So I just say a select star. I mean, I don't mention the field names because it doesn't make a lot of sense. You could, but again, I've given you these examples. They may be not the best of the examples, but at least you know that they exist. Okay, so where this JD titles, this is where they are equal, right? Is equal to JL title. Kind of look at it this way. You're first getting all those, to me it seems more work, but anyway, you just have to know about the verbs so that they, and I should maybe read a little about exist and not exist in terms of efficiency, right? I didn't do that. So basically from job listings table, you're picking up those titles where the titles are equal, and you're saying pick up only those titles from the job desired table where such a record exists. That's what it is saying. So does that record exist? So you're basically, you say, but it doesn't match. I mean, you are only picking up titles from there, and you're picking up the whole record from here. That's what they exist and not exist in. It just means, does that record exist here? That's what it says. Selecting only title doesn't matter, right? Selecting only title. Selecting means just showing the title on the screen, but keep in mind you're selecting the whole record from the job desired. And they don't match. When I say don't match, I mean their structure doesn't match. So this is what exist is. So we should again have the same answer. Again, just showing you both. There it is. Just showing you the 3 different ways of doing it. So that's the third verb. It's again called a correlated query. Again, see, notice in the inner subquery, you are referring to the table that is outside. That's why it's called a correlated subquery, right? So maybe you will have to have, this doesn't need to, but if you have a situation where there is nothing else that is possible, then you may need to do a correlated subquery. The 7B is very similar to what we've done in 7A. All it says is find all the job titles that are desired by more than one and are in the job listings, right? So it's not only saying are more than one, then I simply have to do a count on job desired. But this one is saying, so let's do, you can do whatever you want, like whichever you want. Okay, so I'm joining these, right? So these tables are joined. But now I only want to pick up those. So I've done a natural join. If you want to write an inner join, it's up to you. Like it doesn't matter, but anyway, just so that you see everything. Right? So now if I use a comma, I'll have to give a condition. So these 2 tables are matched on titles. Right? So these 2 tables are matched on titles, but how do I now see that there are more than once? So 2 or more, right? 2 or more. So more than once, I only want to show I only want to show those titles. And do I need a distinct here? That's another thing, but that's a part. We'll talk about it afterwards. People who have, I don't think we'll need a distinct here because it's just counting. Okay, complete. What should I do? How do I count? Remember your group by? So group by. How are you grouping by? Title? Whose title? JD. Right? And when you're grouping by, what do you have to do by group by? Having. What should you be having? The count of these titles. Should be greater than or equal to 2 or greater than 1, whatever makes more sense to you. So refresh your memories. Where to, from, and having to group by. And why do we group? Group by just means put them together. Right? We did a lot of these in the cookies sale example. We did a lot of grouping there. So group by simply says put them together. So how are you grouping? You're putting titles together. Then you are saying the title must be greater than 1. The count of the title must be greater than 1. And if it is greater than 1, spit it out. Why do we need these 2 tables? We have to join the 2 tables because I only want to pick up those records that occur in both the tables. Here distinct will not make sense. I don't think so because I just want to show anything that is greater than 1. So definitely I'm not showing all of them. So anything greater than 1 means it's more than 1 means like show it once, right? I don't think we'll need distinct. So computer programmer should be the only answer in this one. Baker was only desired by 1 person. Uh-oh. So there is something, right? No, 2 rows. Can't have 2 rows. Baker was only desired by 1 person. So something is wrong. What did we miss? Oh, we are having a wrong answer, guys. Why? Job desired, pick up the title. The title should be equal to the JL title. Group them by JD title, not by the JL title. Be careful, we have to group them by JD titles. We're having the that are desired. So desired means coming from the JD table, JD, JD, JL. The title should be equal What is wrong? I don't have a query interrupted, so do I have an error? No. Yeah, something is wrong. What's wrong? Greater than 1. It shouldn't show baker. We didn't have more than 1 people showing bakers, did we? More than 1 people desiring a baker job? I don't think so, no. Do we have more than 1 baker jobs? Maybe something we are doing wrong here, no? No. So what is wrong? Logically, doesn't seem anything is wrong, but something has to be wrong. Okay, let's look at it. Select those titles from the job desired table, match them where titles are equal. That's strange. Let's do something here. Right, so this should give me all titles. Computer programmer, programmer, and baker. Okay, that makes sense. Okay, so now after this, group them by JD's title and then having count greater than J. Oops, what's wrong? That is strange. I mean, I don't think natural join will make any difference because where is not clashing with group by at all. You see logically anything wrong? Select the title from the job desired table, join those. So this answer is right. So the joining is working fine. And then I say group by JD title. So this should group together anything that has count greater than 1. Strange. Logically, it looks as if it should be fine. I don't know whether I have it somewhere on my. There it is. I've just used the word inner join, doesn't matter. That is strange. Because logically it looks fine, absolutely fine. I can try natural join because the where condition will go, but that doesn't make a difference at all. It shouldn't make a difference at all. Where has nothing to do with the clash of group by. Am I grouping it right? By JD title. Yes, I'm grouping it right. If you're getting the right table, okay, let's try it. Nope, still not. So something is wrong. What is wrong?
And this count isn't even working.
Oh, the count is not working?
If I even put JD title greater than 5, it still shows the same.
It has to be the greater than 1 should be outside this.
Having thing isn't working.
The having isn't working.
The count and then.
Oh, I see what you're saying. Oh, thanks. Yeah, I see what you're saying. There. Yeah. Yes. Thanks. Right? Logically, like the condition, you're not counting JD title greater than 1. You're counting the JD titles and that should be greater than 1. Perfect. Yes. Thank you. Because like, how can you count JD title greater than 1? So therefore, I think it just ignores the whole condition. Same thing. If something doesn't work, if the answers are not right, that means something is wrong logically. And this was the logical error. Now it makes sense. You're saying count the JD titles and those titles must be greater than 1. So last one. We should only see computer programmer. Perfect. Right. Thanks, Minnie. I should have just scratched my hair, right? Because you see and you say, what's wrong? Logically, it looks right. It's just the wrong way where I put the brackets. And it makes sense. You can't count something. You're giving a condition inside. And syntactically, it is okay. Logically, it cannot make sense. So it just ignores the having and gives you it. And the answer is incorrect, right? And the answer is incorrect. That takes care of my contacts jobs too, right? So you learned quite a few things today. Like it was definitely, you learned about efficiency, different ways of writing it, combining, joins, subqueries, combining. Something that was absolutely new was the exists and the not exists, which was correlated subqueries. And then this one was the count you've done before, and the round function, which you may not have thought of. You can use the cast also. Cast is just longer and the round is just shorter, right? So now we have a few minutes, but definitely can't waste any time. So please pick up your sports. This is the last one that you had last week. So definitely I don't think we'll have, next week we'll do the extra labs then. Okay, we'll do the extra labs next week, whatever we can do. So the extra labs are already on Blackboard. You're most welcome to download them and go through them and work through them. I'll give you their solutions next week. I will. Once you're done, then you can compare my solutions. And again, as I said, they're just practice. Okay, so this is about some sports. I just copied it from somewhere. So if the field names are not according to what I use, and notice player number and player name, if you notice, they're not using the underscore, but the other naming convention, I just didn't bother to change it because then I had to do it so many ways. I necessarily don't like all the fields they're given, and see, they're mix and match. How player number is in capital and then the birth date is using the underscore. So it's a poor script written, and again, post code doesn't make sense to me. I would call it postal code. So we can do, I mean, at least if you want to keep with everything, I can at least do this. Let's do this at least, because this is, it's quite untidy. So let's replace at least the birth date, be consistent at least in this. Sometimes I pick up examples and then I don't change them just because it's more work. Then I have to kind of go through and see. So that's the only thing, at least it will be consistent, right? So the tables and all was named as I do them using the underscore, my databases and so on. And if you don't like it, you can change those too. But I didn't change the fields and everything that was given. So here is a database that consists of information about players. Again, quite common if you go to the web and look for information. And in the players table, there is a player number, a player name, initials, the date, the sex, joined, street, and so on. And the primary key is the player number, right, which is unique. You could have given it auto increment. There was nothing wrong in it. But as I said, I didn't touch it at all. I just took the data as was given to me because there was a lot of data. So that's one table, information about players like your my contacts. And then here is the team and the captain. So basically the team number, which is again a primary key, and a captain, which says definitely this captain has to be a player. So here I've just, you'll say, oh, but that field is called captain. Keep in mind, field names don't have to be the same. So this captain, it makes more sense here calling it captain. Team has a captain. It is referencing. I chose not to give my constraint a name because it is not necessary. This captain is referring to a value player number in the players table. Makes sense? It's a foreign key. The division is just which division it belongs to. So the team number is again a primary key. It could have been an auto increment field. I left it alone. Then there is information about matches. Which match, which team played it, the player number, how many were won and lost. The match number is the primary key. The player number has to come from the player number of definitely your table. And then the team number has to refer to a team number from the team number table. So definitely all these tables are related. Okay, let's look at the penalties now. Penalties means, players pay penalties. So which payment number, what, again, the payment date has come here. I don't know why, only with the date it has been done. So let's take that's strange, right? Something to do with date has been put in. I don't know why, but anyway, let's do a replace all. Hopefully I won't have any syntax errors. So that's the payment date it was done, the amount, which I have taken to be decimal 7,2, or they have taken, doesn't matter, which is logical. It could be a dollar amount and could have cents with it. The primary key is the payment number, and the foreign key player number definitely has to be a player from the table player. Then comes committee members. A player can be a member of only one committee. That's a restriction that has been done, and I've kind of mentioned it because in the queries we'll need it. So again, the player number, the begin date, the end date, for whatever reason, right? All dates have this. At least, so again, I'll I'll just make it consistent. And then there is an end date. I'm not sure if they're following any convention. If there is something that the date cannot, that doesn't make sense to me. But anyway, here there is an end date. And then the position of the person, position means are you the like a president or the vice president? The primary key here is a combination of the player number and the begin date, because many people can begin on the same date. So the combination is so I can, you know what, a player can be a member of only one committee. So I could have taken the player number could have been a primary key in this case. What do you say? And this was again, if it was only the player number, the foreign key would be a one-to-one relationship. Why is begin date required? Now that I see it, a player can be a member of only one committee. So this player can only be a member of one committee. So the combination is not required. Begin date and player number is not required. Because that restriction is mentioned, a player can be member of only one committee. I think we can do without the begin date, because one member can only belong to one committee. Yeah, I don't think we need it. I'll try it afterwards and just remove the begin date and see. Because logically, if this is what is given, we'll look at the committee table in a minute and see if there is anything there, then we'll do it. So here are the table players, right? So since it was so much work, I kind of didn't want to change it. Here are the teams. So just populating it. Here are the table matches. And here are the penalties, which date, on what date it was done. Oh, there is two with the same. So something is wrong here. So that comment is not right. Populate the committee members table.
Each player is multiple times.
Yeah, each player. Oh, you know what? If you notice, no. This can happen, and that's why. Now I understand. The same player was a chairman first, and then so he was a member first. No, he was a chairman first, and then maybe when he came down to a member, his information is present again. So that's why it's a player of one committee. But how do we distinct the committee? Does the committee have, so the combination therefore is chosen because the positions are different. The positions are different. So if this, so either you remove that information that he was ever a chairman, which you don't want to remove, but if you want to keep the combination, then this has to be unique. So the member is of one committee only, but notice how their positions are different. So the same member 6 was a member, then a treasurer, or then a secretary, or whatever. So that's why that combination is chosen. That's why that combination of begin date with player number is chosen. So only player number will not work. Definitely it will not work. Looking at the data, it will not work. So the combination of the number and the date is what it is. So the end date. So this person is still a member. So he was a chairman and then now has gone to a member. Therefore that requirement. So yes, a player is a member of only one committee, but in the same committee he can have different positions. So maybe let's just put this, because it is a little confusing, right? At a time, but can hold up, so can be a member of only one committee. So let's say, but can hold different positions. So at different times. Because it otherwise means why is that key being taken as a combination? Right, so he can be only, or maybe that's what it meant by saying can be a member of only one committee, is only one position. Maybe that's what they meant. So since it's not my table, I can't say a lot, but I can infer from what it is saying. And if you look at the data, that's how you can infer it. So this person was a chairman first, is now a member, was a treasurer, is now a chairman. So things like that. So therefore null, when you see null, it means this person is in that position right now. So maybe if you want to say what is the current position of a particular member, then you will have to look at the field end date is equal to null. And that's how you will know that what is the position of the person. Okay. And then all I did was, so let's see if I've made some changes, but I haven't made changes that will syntactically matter. I just changed the names of the dates, the underscores. And here are the 5 tables. So that's the players table. Then comes the teams table. So who's the team, who's the captain, and the division they belong to, whatever that means. So definitely these values have to be drawn from here, right? And then the matches. This match number was placed by this team number. He is the captain, right? of that and how many were won and how many were lost. And here are the penalties. So can a person pay more than one penalties? Yes, we see. It can happen. A player can have more than one penalties. And then the committee members were simply saying who and when. So this combination, the unique, the player number and the begin date are unique. You can't begin at the same date. The same player can be a chairman, and so that's the positions that is different. Right. So that's now just so if you change that comment, it will make more sense. Okay. So now our next job. We won't be able to do a lot, and I'm sure we won't be. But anyway, so what I've done here is there are not many questions. There are 4 questions, but of course they will take time. The name and initials of the players for whom at least one penalty has been paid. So again, you can draw the did I run it once? Yes, I did. What did I call it? DB player, DB sports. Thank you. DB sports. So if we want, and that's what we should do, we can go reverse engineer and go on DB sports S. Oh, now they're all, no, there are some here. DB sports. There should be a PQRST. There it is. I think I need to clean up my databases. Oh, the sorted lines and the broken lines, we had figured it out, right? They were to do something with an association. Okay, so that's your, again, everywhere it draws a one-to-many relationship. In this one, we can't say anything, but that's what it does, right? Okay, so there is your table, and it says, let's look at one question at a time. It says find the name and initials. So that means there is a name and there is an initial of all those players for which at least one penalty has been. Oh, at least one means has to be in the penalty table. That's all it means. At least one means they are in the penalty table. Okay, so let's go back. So name and initials. So let's select the name and initials. So let's kind of go with, if you like, the table players, I'll just call P. So we need the player name. Now I'll have to look up these names because it's not in my. Okay, so those are the player name and initials for your information. Those are the fields, and that's how they are called. Okay, from which table? It says do a join. Okay, oh, you know what? We can do a left outer join. Penalties will be less and players will be more. You know what I mean? Like kind of thinking. So you can say, oh, let's do a left outer join. So again, if nothing is being mentioned, you can do whatever you like. So I'll write both of them. So from the table players is your, oh, we called it table players. I'll call it P, and the other table was called penalties, I think. Yep, table penalties. I'll give you the name so that it's easy. You don't have to keep looking back. Right, and where is your where condition? So again, you could have done penalties and players. Penalties and players. That's the penalty. Player number is here. Oh, they have a natural join. You can do a natural join, guys, because they have the same name. But if you don't want to kind of think about it a lot, you can put a where condition. For penalties, you can say PN if you like. Nothing stops you. So they are joined on player number. There, oops, there. This is how many people have penalties. At least one means everybody, anybody who's in the penalties table. Definitely, if we were talking in terms of a better join, we would do a left outer join. So penalties table is hoping the that is smaller. Hoping that table will be smaller just because, I mean, not every player will have a penalty. And you will find every record in the penalty table will have a partner in the players table. Has to have a partner in the players table. From where we are. Okay. So that was an inner join. Again, inner join in our case again may be less efficient just because not every player will have a penalty. And again, I'm doing outer joins and a left outer join for the simple reason because we know that the right is not available in all relational databases. Make sense?
Is it left
Oh yeah, I
out?
forgot the PN here. Yes, thank you. Right, we should have the same answer. So these are people who have a penalty. I said at least one. For a minute, I thought, what does at least one means? One means one or more, so everybody has to be in the penalty table. So both joins will do, right? I'm sure I've asked more. We can come to more in a minute. Oh, I did ask for an outer join. Okay. And we'll come to a subquery in a minute. Okay, so let's try this. So anybody who is in the penalties table has to be in this answer. They all have at least one penalty. Quite a few people. Oh, maybe distinct would be a good idea. I see Baker thrice, Moorman, Collins twice. So distinct is a good idea, right? Because we are seeing, and again, if you wanted to do have two or more, we'll just do a group by and having. If we said three or more, we'll just have a group by and having. So after you see it and you say, oh, the same person, you can leave it there. I mean, as I said, it's not a necessity. If nothing is being mentioned in the question, it doesn't say only show his or her name once. But if you want to, all you will do is you will put your distinct in front of it, just because we saw the answer. If nothing is mentioned, both are correct. Like I can talk of marks because I haven't said I only want to see it once. There, right? So you don't have to, but it depends on you. Again, please remember, you can replace the comma by natural join. You can replace it by inner join and use the on condition. So all these are just various ways of doing it. You don't have to necessarily do it. If I wanted to, yeah, I could do it with the left. I could do it with the right outer join, but then I'll only pick up those tables which I'll have to use the is not null condition. Why should I do it? So this is a better way, but you can do it. You can always use the using word if you like, because again, the field names are same. Right, okay, now let's write it using a subquery. So if I said, we'll do it afterwards, do I have a B part to it? Who paid no penalties. Okay, we'll do the paid no penalties afterwards. I was just thinking if these are people who paid penalties, what about people with no penalties? Okay, so in case of subquery, oh, okay, so find out the player number. Select the player number from the penalties table. This is your player number from the penalties table. So these people have penalties, right? And then what do we want? The player name and the table. Again, if you don't have to, you don't need to. I do a copy and paste, so I keep it. Okay, so select those people from this table where in. So I will need a bracket here. We'll have to stop here, I think. Right, so again, distinct player number and initials. Do we need distinct here? No, we don't. Notice we don't need it here because this guy will only occur. You're picking it up. Oh no. So from which table are we picking it up? From the, what was the other table, guys? Players. We'll have to stop here. Here. So since you're picking it up from the players and there's only one record for each player name, I don't need a distinct here. Right? I don't, because I'm saying the player number, and maybe two people have the same name, but that's okay. Can't do much about that. Right? So should have the same answer. So let's do it. And the last three answers should be the same. So we are only showing it once. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We'll stop here. We'll continue to work on this next week. And if time permits, the extra labs. Right? Okay, I'll put this on Blackboard for you guys, whatever we've done today.